back. I'm delighted to be joined by Chris Nash, who's the Senior Product Manager at Indium Corporation. Welcome, Chris. Nice to see you today.
Nice to see you, Trevor.
Yeah. So we're one of the products that you're showing virtually at the event, or you wanted to talk about, is your Durafuse product. That's your low temperature solder. Tell us a little bit about that, and what's the melting temperature range of Durafuse at the moment?
Sure. So, I think Durafuse LT is one of the coolest products on the market right now. Its patented technology is a low melting point alloy solution that's going to provide drop shock performance equal to or better than SAC 305, which is unprecedented for a low temp solder. The melting point or the reflow, I should say, of the alloy system, we like to keep it below 210 degrees C. So somewhere between 200 and 210 degrees C. But that optimization of the reflow process is going to be key for increasing and outperforming the SAC 305 alloy from a drop shock performance standpoint. Right.
So I'm guessing the reason that it's performing so well in the drop shock is because it doesn't have bismuth in the alloy. Am I correct?
That's correct. That's correct. Bismuth by nature is very brittle. So we want to do everything that we can to eliminate bismuth for applications that require drop shock performance. Now, obviously, all applications aren't going to require drop shock performance. For instance, TVs, servers, that kind of thing, where they're just going to sit in a room. They're never going to be dropped. If they are dropped, you're most likely going to fracture the screen on a TV, for instance. So the bismuth alloys can be used in those instances, but when you're talking about, say, mobile devices or tablets or PCs, even PCs get dropped every now and then. Laptops. I can't recall the amount of times I've dropped my laptop while traveling somewhere. So it's important to have the drop shock capabilities with any of those types of handheld devices.
So what's in it? If it doesn't have bismuth, what is the composition of it?
Right. So it's a proprietary blend of primarily a low temp indium tin silver contained material and then a SAC material. And they're mixed together to create this new proprietary alloy solution.
Okay. Keith, have you got a couple of questions on
it? Yeah, I mean, one of the things that I've been involved in a lot recently is the inert or notness of the flux once it's been through reflow or hand soldering or whatever, because everybody's worried now about Roche tests and all the other stuff. So what's the situation with regards to the residue?
Sure. So low temperature makes the residue reliability important. It's something that's a little more tricky and a little more difficult with low temperature. But we design our materials, our flux residues, to be completely benign after reflow. They pass the standard J-standard SIR testing, the Belcore SIR testing, some of the enhanced SIR testing that the industry is talking about, especially in the automotive realm, where tighter, your voltage is higher. So it's important that we're considering all of that into the design of the materials and the design of the flux and the residue left behind. So with a no-clean material, it is truly a no-clean material. You don't have to worry about the electrical reliability of the flux residue after reflow.
Right. Oh, that's certainly good news. And what about testability?
Testability is always a challenge with a no-clean flux residue. I think, that's more, we see that more with SAC materials. As OSP coatings on boards become more prevalent, I think people are used to leaving, say, an immersion tin or immersion silver or ENIG board unpasted. Now with OSP, you have to paste over the copper OSP. There are some probe technologies out there that say that they can penetrate the OSP, but most times our customers are forced into pasting over. That makes the penetration of the flux residue important to make intimate contact with the solder underneath the flux residue. Now, we designed a number of flux residues to be penetrable by the ICT pin. And usually they're either a soft material, a soft flux residue after reflow, or they are a fast break, fairly brittle type flux residue after reflow. So there's a few different ways to go. The low temp actually makes it a little bit easier because you're not baking the residue and polymerizing the residue as much as you would with a SAC alloy. So, you know, it's all really going to depend on the ICT process that's being implemented and being employed at our customer. We can certainly help provide guidance into what might work a little bit best for the application at hand.
Right, that's great. So do you think LTS solders or low temperature solders are going to increase by the number of applications going forward?
I think so. You know, I think we're seeing a kind of a technology inflection point where people are looking at low temp solders for a number of reasons. Temperatures, they have temperature constraints on components, or the PET or flexible substrates that they're using can't go to the 250, 260 degrees C range. I think you have some soldering applications where our builds are becoming three-dimensional and energy costs. Although I really haven't seen a study in the industry to say that that's in fact the case. I think that would be a fairly complex study, and it would depend on the energy cost wherever you are. But I really do think that the industry is moving more and more towards low temperature for a number of reasons. It is becoming more prevalent, more important. And Indium Corporation has been involved with low temperature for probably since the entire history of Indium Corporation, starting in 1934. Right. Our Indoy #1 is a low temperature indium container. Yeah. So we're very familiar with the space.
Yeah, I certainly think if you're not driving your reflow oven as hard, you're bound to be saving energy, somewhere down the line in electricity costs, etc. But anyway, we need to move on because you've got another product we want to talk about, and that's the CW232, a flux-cored wire, which you've specifically designed for robotic soldering and laser soldering, that kind of thing. Tell us a bit about that.
Sure. So robotic soldering is becoming more prevalent as well. Whether it's for interconnects of connectors in a secondary process, or if it's for an entire board. Instead of hand soldering, robotic soldering is going to be much more beneficial and reliable, and give you the best results possible. Whereas a hand soldering operation, one operator might result in different process techniques than another. So the 232 is really designed for the robotic soldering applications. It's a very, very fast wetting material, the flux-cored, which allows for fast wetting to the pins so that you can increase the throughput of your process. It also will leave low spatter, which is extremely important from a cosmetic standpoint, but also a electrical reliability standpoint, because you don't want flux going onto gold fingers of the board where you're going to plug it into, say, a motherboard. You really need to be careful with the flux spattering. Now, on the hand soldering side of things, flux spattering is important because the operators tend to get little burns on their hands. So it's important for a safety reason to have a low spattering option as well.
Mm-hmm. Okay. How do you manage to reduce the spatter using this?
Well, it's really all in the formulation, right? So it's a proprietary mix of chemicals to create the flux-cored that we would put inside of the wire itself. it's really unique. There aren't a lot of solder companies that are really aimed at lowering spatter. A lot of people are content with their solder wire formulas. Speaking from a competitive standpoint, in Indium Corporation, we're really looking at moving the industry ahead with new materials all the time, new products, bringing them to market and making the industry better as a whole.
Well, not a lot of margin in the core wire business, so I wouldn't imagine, you know, there's a lot of appetite for investing too much R&D dollars into it.
Yeah, that's correct. I would say it's a fairly low margin product, but at the same time, you still have new challenging processes like robotic soldering that are going to need a new product to work properly. It's still important that we're focused on all aspects of the solder industry and investing in the solder industry and our product development so that our customers can benefit. The same goes for wave flux. You know, I think a lot of times wave flux is, you know, 15, 16 years ago when I started in the industry, everyone said that wave flux was going to disappear. Well, it's still here. You know, selective soldering is still here. Wave flux is still here. We're still aimed at improving our flux chemistries for wave flux and selective solder. So there's a number of materials that we've brought to market recently, and they're really fantastic for helping out with some of the new challenges that the industry is facing.
Keith, have you got any input on this flux-cored wire, the CW232?
No, I think, Trevor, my only comment is it's nice to hear a company with a holistic approach to the whole of the, let's say, the various processes that are used within the industry, rather than, you know, just going after the, you know, the high return stuff. So yeah, it's good to hear that, you know, people are still working on cored wire and wave soldering flux and all those things that, you know, through our lifetimes we've heard many times they're going to die.
I think you're right. I think the solder paste is still a primary focus for Indium Corporation. Don't get me wrong there. We have a number of new materials and tried and true materials that the industry is currently using. 8.9 HF, for instance, where it really can't beat it. It's one of the best solder pastes on the market, if not the best. It's kind of the new 92J, if people remember the 92J from the tin lead days. So,
oh, yeah.
You know, 8.9 HF has been a very successful product for us and will continue to be because it was really developed ahead of its time, we believe.
Right. Well, great. Well, thank you, Chris, for coming in and telling us about both these products today. We wish you every success with it, and we hope you have a good rest of the show at Apex.